So we've lined up more than one speaker for you today, and we are very privileged to be joined by Dr. Manashree Jugmohan-Naidu, I hope I said that correctly, Director for Agricultural Biotechnology at the Department of Science and Innovation. Thank you, Doctor.
And thank you for the opportunity to address you today on this very exciting occasion. And having been at the Agri Tech 2020, I think there are exciting times ahead. Following from Priyash's presentation, I think being a government official, of course, my talk is a little bit more policy focused and about how we're doing it. But I think there's three things that I want to pick up from Priyash's talk, and these are, when we look at data and how it impacts what we do, it's the issue of relevance, which data, which technology, for what purpose. Secondly, the issue of access. How do we set ourselves up so that everybody has access to the same data systems, to validated scientific information that allows us to move forward? And the last, in terms of really informing and harnessing and building on the systems that we have. And the last point is the issue of sustainability. And I like the fact that he talked about partnerships. So a lot of my talk, while it might be a little bit more policy and research focused, I'll try to bring in these three aspects into it. So just a quick overview, because I thought for this talk, because we're talking about Agri Tech Africa, what are some of the key policy frameworks for agricultural innovation in Africa? And really how, in terms of a bioeconomy, how are countries in Africa positioning themselves to innovate in terms of a bioeconomy? And lastly, the South African implementation, and I'll talk to a little bit around the partnerships that we are trying to build. So I think it's very clear, without going into the detail, I've not been known for giving short talks. I may be short, but I just want to touch, and I'm happy to share the presentation later, but we definitely have sufficient policy guiding us in terms of how we build an inclusive and sustainable agriculture across Africa. Secondly, in terms of making sure that through these policies they inform how and lead us in terms of building knowledge-based and innovation-led society. And that is coming from STISA 2024. Food security, as already mentioned, is critical, not only in terms of household food security, but national food security in terms of many African countries. And so within that, if we want to eradicate hunger and ensure food and nutrition security, there's also a case for how do we increase investment in agricultural R&D. There's a new EU innovation agenda looking at how we support sustainable and inclusive growth and job creation. And once again, building on a key thing, a take-home from this strategy is, how do we make it real? How do we bring it home such that the technology we invest in impacts the lives of people? Moving on, just in terms of the definition of the Montpellier panel on what is a bioeconomy. So it says a bioeconomy is the production, utilization, and conservation of biological resources, including related knowledge, science, technology, and innovation to provide information, products, processes, and services across all economic sectors towards a sustainable economy. Of course, here we're talking more on the agricultural sector, but just homing in on this study. And there were 4 case studies that were done for Africa. The study report was released in 2020, and they looked at how we use biomass and our global innovation index to choose which countries they would reflect on. And this is looking both in terms of the innovation index, both input and output innovation measures. And so it's really about how do we set ourselves up in terms of having innovative institutions, facilitating innovation activities, supporting human capital development, infrastructure, market sophistication, and business sophistication. And outputs are then really the outputs from innovation activities, and really in terms of building that knowledge society. So the focus was on Ghana, Namibia, Uganda, and South Africa, as these were considered 4 countries with the highest propensity to support bioeconomies in Africa. And now in terms of Ghana, maybe just to mention, so Ghana has a rich plant and animal biodiversity, and they focused on agriculture, forestry, energy, and waste management. But they have started to support industries for cashew, shea, and their byproducts. They also have support for their tertiary institutions in terms of science, technology, and innovation. And they have used public-private partnerships to advance the development of their herbal medicines and take it into standard healthcare delivery. The second country I just want to home in on is Namibia, who also has positioned STI as a key enabler in the country, and they have focused on the importance of game meat and developing those food value chains. So just in the next country is South Africa that they focused on. And given that we really, and I'll talk in a minute about some of the things that we're doing, but we have the most advanced bioeconomy in Africa. And this is due to the fact that we have good IP systems, we have good collaboration, and good policies that support small businesses, that also support a leading biopharmaceutical and biotechnology sector. So incidentally, we've just recently in the health sector been awarded what they call, the WHO calls maturity level 3 in terms of vaccine manufacturing capabilities. The highest level is 4, so we've been awarded level 3, which I think is quite an achievement, particularly through our efforts in developing that tech transfer hub. The last country they looked at was Uganda, and Uganda has quite a number of incubators at Makerere University and the Uganda Industrial Research Institute, which supports bioenterprises. They also are promoting the domestication and commercialization of traditional medicines and biopharmaceuticals. Now, some of the key things to take away from this study was that we need to really identify gateway sectors to which to initiate development of transition to a bioeconomy, strengthen links of R&D to markets, because the market is very important, develop the demand. If there's insufficient demand for a product that you're developing, it won't really have and generate the value. Also set up of national advisory boards to inform and guide the development of bioeconomies. The next part that I'm going to talk to is about the South African experience and key enablers for implementation. Our agricultural bioeconomy in South Africa, we have good science, and our science researchers have some of the greater than the world average in terms of scientific citation indices, and we have good systems for supporting entrepreneurship as well as tech transfer and commercialization. But we need to ensure that we invest more in terms of venture capital investment, in terms of getting technologies in the market, because we have good science and we invest in good science, but we need to get those products, we need them to be used for the benefit of society. So it's really the issue of where should we be intervening to improve efficiency, but also how we should be intervening. In terms of South Africa and our new decadal plan and our priorities for agriculture, we're really guided by our new decadal plan, looking at how we can modernize productive sectors of the economy, such as agriculture, mining, and manufacturing. Now, in terms of agriculture, guidance through the decadal plan is that there needs to be inclusivity and transformation, as well as an environment that supports partnerships, creativity, learning, entrepreneurship. So at the moment, we're busy developing an STI roadmap for agriculture, but we started already with our bioeconomy strategy, of which agriculture is a key pillar in terms of how we use technology to support socioeconomic impact. Technology. Secondly, just in terms of our agricultural bioeconomy, the theory of change of how innovation, science, technology, and innovation is becoming the key buzzword, can revitalize agriculture is that through key interventions, outputs, and outcomes in agriculture to address the key challenges that we face, we can support increased growth, we can support decision support tools that help us to promote productivity and incomes, and we saw some of that through some of the digital agriculture. We can also support inclusion and competitiveness, and the way we do that is through crop or plant or animal improvement programs, animal improvement, agro-processing, also value chain analysis, and I've got an example in terms of first identifying what is the key opportunity in a value chain. And whilst we focus on ensuring that we cross the divide between the first and second economy and support new and emerging farmers to become commercialized, we also want to support digital technology that enables us to do this more precisely, more efficiently, and we want to do this through coordination, facilitation, and multidisciplinary and multi-institutional agricultural innovation programs to drive these productive value chains. This slide then just sort of mentions one of our key instruments, which is the ABER program, which does exactly that. And our implementation agency is the Technology Innovation Agency. We work with many partners, of course, including co-funding bodies, government, RDI, farmer development organizations, as well as private sectors and international organizations. I'm not going to go into this slide, but I just want to home in on this slide here. Now, in terms of modernizing agriculture, a lot of our focus is on molecular breeding cultivars that are resistant to pests and diseases, but also drought tolerant. And we also want to focus on smart digital and precision agriculture as a means to ensure that we increase such efficiency. Now, modern agriculture provides us with many tools and technologies, but we also need increased access, like I've mentioned at the beginning, in terms of decision support tools that impacts on farming operations with increased accuracy, speed, reliability, and agility of the systems to be able to respond when there is a crisis. And some of the examples, I've mentioned the molecular breeding for resistance to pests and drought tolerance. There's also a lot of work being done on phenotyping, indoor and in-field, as well as cutting-edge platforms for decision support and efficient planning and management of agricultural fields, monitoring crop health in real time, trying to identify stresses early, and there are a number of projects on the ground, and I'll mention one or two. Predictive modeling, really looking at how we can model microclimatic conditions to be able to predict disease outbreaks. Multi-sensor satellite technology using remote sensing and drones for predictive modeling. So an example is the CSIR Precision Agriculture Information System. Secondly, smart farming using data from long-term rotational trials that help us to assist farmers and reduce input and increase yields. And these really focus on, really helping farmer what to plant, when to plant, mitigation, seasonal effects, the issues around climate change. The throughput system, which really assists with water use efficiency, and the National Biosecurity Hub, which we just launched last week, which combines crop protection research, data collection, and warehousing to develop an open access platform for decision making. And that is really where we want to make sure that there's scientifically validated, collated information across the sector that helps us to do that. One of our oldest flagships is the wheat breeding platform. And so while the department invests in pre-breeding work, there's also support from industry, industry to sector to support the breeding work. And this is proved to be a win-win situation where we're able to complement the investments that we make. And there have been over 30 new cultivars released since 2015 by the individual breeding programs such as ARC, Syngenta and Corteva. But there's also a lot of work also being done on phenotyping and really looking at indoor and outdoor phenotyping to look at how we can speed up the way in which we deliver new cultivars to the market. I won't go into the detail of this, but digitizing the action of phenotyping makes it more repeatable, the data is less biased, and it's transferable between labs. Now, some of the applications that are currently out there is terrestrial-based imaging field tools, making use of multispectral thermal cameras such as LIDAR. Because really you want to monitor not only indoor, you're breeding indoor, but you want to do, you also want to monitor outdoor in terms of analyzing the capability of the cultivars that you develop for the market. Hyperspectral imaging, processing such as near-infrared, looks at imaging for fruit sorting in a pack shed, and using this technology, you can actually look at the quality of the fruit. Secondly, research on wheat breeding, where you can look at single kernel, looking at the protein, moisture, or kernel hardness. These are very important in terms of the preliminary steps, in terms of making your product market ready, and determining whether it really will yield the value once it's in the market. The use of drones with multispectral imaging in wheat improvement, where we've actually shown that it can assist with monitoring increased yields. Seed counter based on kernel imaging. This is bulk counting of seeds from a company called Data Technologies, which actually allows you to do this with increased speed and accuracy. Programmable seed color, shape and size sorter, which really looks at seed sorters for grain. It's a fractionator which removes impurities and provides shelf-rated quality foods. In terms of techno-economic feasibility studies, before you invest in a particular technology, it's also important to map the value chain, to look at the real opportunity before you look at what innovation you want to invest in and how it will create that impact. What are the key bottlenecks in the value chain that need to be unbundled in order for your product to be realized in the market? So this is a study that the DSI completed, and we've got various other techno-economic feasibility studies that we're doing. For example, in canola, where we're looking at how can canola grow in the Eastern Cape now that the West is getting drier. Looking at cassava as well as looking at marula. Before we put up a factory to produce high-quality marula oils, can we get the supply and demand side right? We've done some very good work on the Cape aloe value chain development, and this is really looking at entrepreneurs who've developed cosmetics, and now looking at how we can get those entrepreneurs to develop their businesses so that they can put this product in the market. Nutrition security. Now, as we support increased, this is critical in terms of nutrition security, curbing malnourishment. As a farmer plants grain, he needs to be able to plant other nutritious crops that help assist with household food security in terms of combating malnourishment, etc. So we've invested in some of these technologies that look at nutrient dense and drought tolerance in traditional and indigenous crops, amadumbe, bambara, groundnut and leafy vegetables. And part of this is really about access to the technology, about communities setting themselves up. So we had the KwaZulu-Natal Smallholder Association form being developed, and we had the transfer and training of the farmers to producers with the idea that they would develop businesses, and this is sort of on the go. And we work with quite a number of partners. There are other projects that we also work with the oil and protein seeds industry on the processing of soybean. And that is really to look at how on-farm, in small enterprises, they can produce yogurt, soy snacks, etc., which is really about that increased protein content in the diet. The National Biosecurity Hub was launched by the DSI and the Minister of Agriculture, Land Reform and Rural Development. Outbreaks of pests and diseases result in increased losses, they reduce yields, they reduce food security and quality, and they disrupt trade. So we need integrated pest management and innovation, and the National Biosecurity Hub is really about a partnership program in terms of how we can strengthen our biosecurity and use international standards to develop national sanitary and phytosanitary systems, also support the technical and information management systems to meet the SPS requirements of international trade. The platform also will assist us to prevent, respond, and manage pests and diseases, conduct research on known and emerging threats, develop a biosecurity information hub, which has already started, looking at the data warehousing of scientifically validated information across the country from different research programs. And it's really about building those systems that have the pest lists, that have the information on what are the new threats on the horizon, having the scientific capability to be able to respond should it occur on our soils. And during the launch, both ministers signed a commitment to biosecurity in South Africa and renewed focus. Incidentally, what I should also mention is that this story was born out of investment by the DSI in a research program coordinated by Grain SA, where in 2016, we just started to look at a program for looking at quarantine pests and diseases in crops. And the project has grown, and through this program we were able to invest in a national biosecurity hub. This slide just sort of shows you some of the work that's been done on fall armyworm. So a lot of the work, it's a combination of different aspects, both on the research side, putting the traps in the field, looking at heat maps, but also then collating that research information in terms of looking at the numbers, looking at the spread of the disease, and looking particularly where is it occurring, in which provinces, etc. I'm not going to go into the detail, but I can take questions. So, through research and innovation, we can get to this type of data that is more accurate, that is informative, that helps us as a country to make better decisions. We also support skills. This is my last slide. In terms of strengthening agricultural innovation systems by supporting not just masters and PhDs, but technicians, some co-funded with industry, supporting entrepreneurship, enabling retraining and training of extensions officers so they can assist the farmers with better decisions and access to these digital systems. So with that, I thank you.